Hi, everybody. Ahoy. First of all, thank you for coming. Thanks to our sponsors. Thanks to the organizing team behind the scenes that may have not gotten the credit they deserve. Eliza, who flew in from New York, Jeremy, who picked up the slack, Arthur, Nati, Florian, Avner, Kobe. Thank you very much for helping us drive this community and this event. I want to talk for 5 minutes just about what's involved in driving the local community, and for you guys to know that OpenStack Israel is not just one day a year. So in terms of growth, you guys have been here, some of you from the beginning, some are just joining, but not only has the OpenStack global seen huge growth, we have here in Israel as well. Every year we see more and more attendance at our events. Our meetup has grown exponentially. You can find all the information about what's involved in participating in this community at OpenStackIsrael.org. I'm trying to go quickly just because I kind of decided to come on in here in the middle. But really everything that you need in order to get involved. We have a flourishing meetup group that we've had excellent sessions at. You can propose talks at OpenStack Israel under the community tab, and you can definitely reach out to me at any time. I'm happy to get any propositions for talks. We're really looking to get everyone involved. We have an excellent Google Plus group that you guys can definitely post anything interesting to the community, have discussions, start whatever it is that you want to talk about in the OpenStack Israel sphere. We're always looking to get people involved. We have an active Twitter, OpenStackIL. You can use the OpenStackIL hashtag. We follow it. We retweet. This is for really OpenStack Israel is community driven. It's for all of us. It's not just an organizing team behind the scenes. And we really want to make sure that everyone gets involved and gets their voice heard. To that end, we also have a Tumblr that you're more than welcome to contribute posts to, blog posts, things that you're doing on the ground. We know that there's a lot of development around OpenStack in Israel, and not necessarily everyone knows about it. This goes right into the OpenStack feed, the Planet OpenStack feed. So whatever you're doing here on the ground, we need a digital footprint here in Israel. We need people to know what it is that we're all doing and contributing to this excellent open source project. So definitely you can contribute, post, and we'll moderate it, we'll approve it. This is open to everyone to contribute. We have an excellent podcast, OpenStack and Beyond, hosted by our very own Nati Shalom and Shlomo Swedler. Excellent talks. You can follow it on SoundCloud. Our next one is with Arthur and Florian of OpenStack Israel event fame. Yeah, it's definitely going to be a good one and high availability, so definitely stay tuned. There's training. Those who want to get more involved, learn more about OpenStack. There's the fundamentals training for those who just want to get their feet wet. And then our very first advanced training is starting tomorrow with Florian, the brilliant Florian Haas, and it will be taking place at Mellanox. And it's really going to take a deep dive on everything OpenStack. This is our pilot advanced training, but assuming it goes well, and we're pretty sure it will, this is something that's going to be a regular. So if you already know quite a bit about OpenStack, definitely stay tuned for the next advanced training. OpenStack in general, the global community resources you have to you. There's an excellent super user site. There's the biannual user survey. This year we were really urged and asked to get the Israeli people involved, and we did. We sent it out to all of the organizations that we know are contributing code and are doing really interesting stuff around OpenStack, but definitely know that this exists. They want to hear what you're doing, what technologies you're using, what technology backbone. It really helps them understand and develop the project and take it to the right directions that are right for the user base. So definitely have your voice heard. Visit Super User. There's a lot of interesting content there. How you can get involved. Definitely reach out to us if you have an interesting story to tell. If you want to present something new and interesting. So there's definitely ways to connect you to the foundation, get your story heard. Kobe is a great example of somebody who's done a user story with the foundation, and And we've had excellent meetups around the globe. I mean, we have partnerships with the SF Bay meetup and a few others. So definitely reach out to us, and we'll help you get connected to the global community as well. This event is actually the closing event for the EMEA tour. There was the Budapest Day, there was the DACH Day in Germany, and all of these things, we have, it's a global community, OpenStack, so definitely reach out to us and we'll help you connect to the right people. If you want to reach out on anything OpenStack related, openstack@gigaspaces.com or openstackal@gmail. We'd love to have this be more of a community endeavor. So thank you all.
Thank you, Sharon, the one and only, I should say. Just to share with you, she was actually giving birth during the Vancouver event and still was doing WhatsApp while she was giving birth. So seriously, I think one thing that you've missed here is that you get plugged to Sharon if you're joining the community. That's the most useful thing. So right now we're going to do the lighting talks. Who's first online? Marco, I think you're ready. Where is he? Let's do Marco first. So it's going to be 5-minute sessions in a row, and I'm going to have a list of 3 sessions.
Hello everybody, again I'm Marco Ughetti from Telecom Italia. I'm focused on NFV, and this very fast talk is about how to validate the NFV infrastructure based on OpenStack or maybe not. And okay, this is quite important in the NFV stream of activity, because we are in a very complex environment where VNF are requiring specific capability from the infrastructure, and the VNF also are very decoupled by the infrastructure. So we have to validate everything when something is changed. For example, networking, storage, and specific hardware capability can be requirement for different VNF. The life cycle of the infrastructure is decoupled by the VNF, so we need what we think. All of these things requires a fully automated continuous validation. We have to figure out how to achieve this fully automated continuous validation, but we need it, and we are trying to start with our testing lab colleagues to do something like that. What should be validated in an NFV infrastructure? A lot of things, because the requirements are, in our case, business continuity and geographic distribution and geographic redundancy. The business continuity of the VNF depends on the high availability of all layers, starting from the application, because the VNF design is very important. VNF design, the high availability of the virtual layer, and the high availability of the physical layer. The storage architecture is quite important, and also the fine-tuning of the networking. What we have started to do is an internal development in order to overcome the lack of official tool for doing this. And we have developed a very simple tool that includes a management console to deploy, run, and define and test, a set of probes that will be deployed as a virtual machine together with their networking to the infrastructure, and a kind of VNF manager in order to deploy all the stuff and to make the test online. Okay, now our conclusion is that the automation of the infrastructure is very, very important, but is also difficult to achieve. The complexity of the infrastructure means that the predictability of the performance is also an issue, so we have to fine-tune all the configuration, and whenever performance and behavior depends also on their design. They have to be native cloud applications. So next step will be to improve this tool to validate also the application layer and not only the infrastructure. Thank you very much. And
Thank you very much, Marco.
thanks.
Next is Liveperson, Gonen.
I will not start until I have my slides, because otherwise it's a waste of 5 minutes, right? Now you said everybody heard, so I know I can start. So my name is Gonen Wilf, and I'm the head of production at Liveperson. I just need a clicker. Oh, okay. So there's a risk I'm going to burn your retina, but it's a risk I'm willing to take. With the next slide. This is me as Perlman, and when I came to Liveperson, basically there were excellent tools at hand. The Hattori sword, which takes ages to forge, cycles and cycles again, but it does only one thing, and that's very, very expensive. And so when you are trying to do many things with the sword, you just waste your money. People are using just one thing in mind. In terms of what Liveperson was developing, it was a monolithic software that there were very, very few people that knew how it works. And when you drill inside this monolithic software, you see actually discern complexity with the human scale just to compare. Now, when you wanted to fix that, you had to get your projector and just use the Batman signal, hoping that there was going to be a superhero to save you, because only very few people knew how to use it. When you looked at the people, they were fear of doing any change, thinking outside the box. And that's a very, very big problem. You don't want to become an operational expense company. I don't know if many people know this, but this is the one laptop per child. It was dropped in a village just as an experiment. 5 minutes, the kids turned on the laptop, and within 5 months, they hacked the Android inside. This is not a change. This is not open source. This is just patching. This is very important. And when you look at the things you can do in terms of creativity and challenging people, this is just a small example. The next example is really impressive. And when you look at what people can make, this is an actual figure, but this is not a human being. This is an animated figure with all the 33 muscles, facial muscles. And that's something that is 2 years old from a game developer summit by Activision. This is the resolution that you can drill down in terms of how it operates. When you go to open source, don't do this just because it's cool or for the glitter of it. You're going to fail. It's not going to hold water. Make sure that you do it for the right reasons and that you realize that it's a very long road ahead. By the way, this is the Toronto terminal where many of us are traveling back and forth to San Francisco. When you go on the ride, don't be suicidal. You have to make sure that everybody understands that you are trying to achieve. And always have a backup plan. Always have a backup. Don't always reveal it, but have a backup plan in case there is a problem in what you're trying to do. Don't be religious about it. Not everything has to be open source. Not everything has to be a community. Sometimes you need to pay to get the product. But be aware that you have several choices. And last, put your money where your head is. This is me jumping over my coach, who said I'm jumping pretty well. I said, lie down and let me demonstrate over you. Going open source is a constant change. This is the way you're going to do it forever. have that realization in order to move forward. And this is where we are today in terms of the numbers that you already saw. And we are quite proud in what we're doing, but we know that this is an ongoing challenge that we're going to face. Some of the flavors and products that we use at Liveperson, servicing banks and many big telcos and other medium-sized businesses. And that's it. Thank you very much.
Okay, so we got Barak from ConteXtream. I think now we don't have the time check for him, right? We do? Yeah. Okay, excellent.
Hey everybody, I'm Barak Perlman from ConteXtream. We've just become an HP company, so now we're ConteXtream, a part of the NFV business unit within HP. So I'm going to talk about network function virtualization and some specific use case called service function chaining. We'll introduce the service function chaining part and tell you a little about service function chaining, how we built it over OpenStack, and how we use SDN controllers to implement service function chaining. So the previous presenter also talked about network function virtualization. Actually, Telecom Italia talked about it. So service function chaining is a use case for NFV that implements a few value-added services that carriers provide to enterprises or users to enhance their offering to the community. So right now, carriers are mainly giving pipes, and they want to sell more services, so they're trying to find additional services. So value-added services is something that goes well with this concept, allows the carriers to provide more services. So what are value-added services? For example, security services such as firewall or URL filtering or anything that they can offer as software services and not just simple just pipes and nothing beyond it. So this will go on for about a minute, then there will be another minute, just because the slides are made for 1 minute per slide. So we implement the service function chaining, and we use this. We used the OpenStack to implement it, and we actually did a demonstration of that in several venues. And if you're familiar with NFV, the network function virtualization had a place to host such events. So we had an Etsy POC number 15 for service function chaining. If you're interested, just Google that, Etsy POC on service function chaining, you'll find more information. So I'll describe a little bit about service function chaining. Then I'll describe the OpenStack environment that shows how we implemented this. And then I'll just mention a little bit about SDN and how SDN comes into play for service function chaining. So why do we need SDN for service function chaining? In service function chaining, you want the routing or the packet flow to be, to traverse a path that's not the trivial path. So if a user, for example, wants to Google something and, I don't know, go to YouTube or something similar, we need the packets to traverse a few other services in the path. So we cannot rely on simple routing algorithm for that. And for that, we use SDN. So we look at the customer and say, okay, the customer is registered to a specific service, maybe URL filtering, then we need to send the packets to a service filtering value-added service. So this is an example from ITF. There is in ITF a mobility. This is covering other use cases, but mainly on the mobility and cellular case. So we have on the side a few use cases. We have the cellular use case, the DSL, the broadband access, the PON access, and cables. All of them have very similar mechanism in the sense that you have some users on the left and they want to go to the internet to some other users, to some other services such as voice or similar. And in the middle, there are some services you can add on top of that. So the simple connectivity would just, take the the packets from the UEs, send them to the PGW, and then traverse to the internet. Maybe firewall. So what value-added service can you add? You can add content filtering if the user is interested in that. You can have TCP optimization. TCP optimizations allow for improved download speeds, just increase the value of the service provider. And then you can add some caching, CDNs, and similar. So the way this is implemented usually by traditional approach is that you put in line several boxes, big boxes. So each box will implement a specific function. And this is, if you go to some Bezeq or the other vendors, they will probably find similar boxes full of value-added services that the carrier provides. So for example, if you put TCP optimization, it's in the path. And if it breaks, everything breaks, right? All the packets are done. And if you want video optimization, let's assume that only 20% of the users are registered at that, but it'll have to pass the full traffic, right? So it's not only a single point of failure, it usually needs to be very big. And probably one instance of such box would not be sufficient, so you have to have load balancers. So you end up with a very complex variety of load balancers and application servers that are all in line. So service chaining comes to replace that, and the idea is that you only send to the value-added service only the packets that should be going to this value-added service. For example, if user is registered to some TCP optimization, then the TCP optimization service will get those packets, and otherwise it will not. So if you have like 100 gigabits per second coming from the PGW, but the TCP optimization only handles 10 gigabits, so you only have 1-2 instances that you need to implement for this. So this is an example of an OpenStack environment we built. This is the ETSI number 15 that we built for this. We have TCP optimization from us. We are also providing some value-added services, so it's VNFs. And also Skyfire optimization. Right now they're Opera, they were bought by Opera. You have URL filtering. We use Squid for that, open source. And the last one is analytics collectors from Guavus. So if you take an example that some specific user is registered something, then it will only need to pass some specific instances. It doesn't have to pass everything. And all this is built over garden variety OpenStack. We took OpenStack with OVS and everything, and we implemented over OpenStack. So we actually have several network elements. You have the physical elements, the physical hardware switches. You have our own software switches, and also you have the OpenStack network. So the OpenStack networks is what we did is each VNF sends the packet to a ConteXtNet switch. So the packets actually don't flow directly. This is an example of how packets will flow. It'll take about a minute, I think, for the animation to take part. I can click it. Would it help? There you go. So let's take an example of a user that is registered to PGW, going to TCP optimization, then video optimization, URL filtering, and the firewall, okay? So the controller, the ConteXtNet controller selects specific instances for this user. It knows that it knows which services this user is registered to. So it sends this information to select TCP optimization instance 2, Skyfire, no analytics, and then it goes to the firewall. So this is implemented using the ConteXtNet controllers. The ConteXtNet controller selects those instances. So the next one will show actually what is the actual data flow for a specific hop. Let's just look at the TCP optimization and the URL filtering. And you'll see that the packets actually go a long way. So they go from the TCP optimization using some OpenStack networks to go to the ConteXtNet switch, and then go to the URL filtering, then going to the ConteXtNet second switch, and then that's just demonstrating a single hop. So actually you have 3 layers of controllers here. The ConteXtNet controller implements the the VNF connectivity, and everything is going to the ContextNet switches. So the ContextNet controllers control the ContextNet switches. Neutron controls the OpenStack networks. Actually, there are OVSs there that are controlling this or other methods. If you use Dockers, you can use other methods for implementing the OpenStack networks. And the physical networks could be either SDN or not controlled. So this is how SDN comes into play to implement this. Thank you.